It's pink and fluffy, and it keeps us warm. Fiberglass insulation is a great way to prevent heat loss from our buildings. It has a woolly texture, but it is, as the name suggests, made of very fine threads of glass. That's why it's sometimes referred to as glass wool. Fiberglass insulation will reduce energy consumption, but it also reduces waste because it's made from at least 35% recycled glass. The recipe also includes what's called the batch, a lot of sand and smaller portions of soda ash, limestone, and other minerals. The glass, called cullet, used to be bottles and windows. This will be its second recycling. The cullet and batch ingredients spill onto a conveyor belt system, which transports it all to an electric furnace. The conveyor moves back and forth to evenly distribute the cullet and batch ingredients. They seep down and melt into a previous mix, which is now a pool of glass at the bottom of the furnace. The glass liquid now flows out of the furnace and into sloped channels. Inside these channels, the temperature is kept red hot by natural gas burners. This keeps the glass mix in a liquid form as it oozes out of the holes in the bottoms of the channels. The melted glass falls about 3 feet into a spinning bowl. It's called a fiberizer. The spinning action flings the glass through thousands of holes in the bowl, creating thousands of feathery glass fibers. Gas and compressed air pull the fibers, stretching them thinner. The process is a lot like making cotton candy, and the spun glass even has a similar texture. But the fibers will soon become even more like cotton candy. Nozzles spray them with the polymer glue tinted pink. The now pink and sticky fibers drop into a hole in the ground and amass. Then a conveyor belt takes the mounds of sticky glass to an oven. Steel plates compress the pack as it enters the oven that's heated to 500 degrees Fahrenheit. Hot air blows through it, setting the glue. As the pack exits the oven, circular saws cut through it, making 15 to 24-inch wide strips that are called lanes. The lanes pass by a series of poles that push them apart. Next, an inkjet brands each lane with a number that conveys the R value. R stands for resistance to heat flow. It's a measure of how well the insulation will stop heat from going through the roof, and your energy bill along with it. A chopper with big steel teeth now cuts the lanes, making chunks that could easily be installed in an attic or wall. After chopping, the conveyor belt accelerates, transporting the fiberglass bats to the next station. A few at a time, the bats plunge down a chute to a mechanical arm which slides the bats into a compression chamber. There, a hydraulic ram squishes the bats down, reducing their bulk 5 to 10 times. This compaction will make them easier to transport. Now, another ram comes from the side and pushes the stack of compressed bats forward into a spout. The spout is a hollow bat-shaped frame. A worker pulls a plastic bag over it. Then the ram pushes the fiberglass insulation bat into the plastic bag, and the process begins again. A conveyor belt transports the bat-filled bags to a machine that heat seals them. Then they're sent off to be installed.